everyone, I'm Ayako, and with me today is Melissa, Louis, Joe, and Zach. We are Taco's dream team. The app we developed is Table Tracker. Table Tracker is an app designed for restaurants to keep track of the order journey. We used React, Firebase Authentication, PSQL to help users streamline getting an order from the waiter to the kitchen and to the plate. Louis will now take you through a demo of Table Tracker.
This is our sign-in page, which uses Firebase Authentication. Here, users can log in as either a staff member or admin, depending on their role. Users will have restricted options as a staff member, with only admins able to make changes to the menu and create new users. Once signed in, users will be taken by default to the table page, which displays the tables in the restaurant. The colour of the table indicates the journey of the food. Grey means the table is vacant, while red means that that table is occupied and waiting to place an order. Orange indicates that an order has been placed and is in the kitchen, while green tells us that the order has been served. To activate a table, users click on the table to bring up options to activate or deactivate a table, as well as to place an order. Activating the table updates the table view, changing the colour to red, while Place Order brings us through to the menu page. The menu is split into 4 different categories to make it easier for the waiter to navigate. We found that a list with no categories led to a bad user experience. Each menu item has an Add and Subtract button, which alters your order, and the full order can be found at the bottom of the page. The order can only be submitted once it has at least one item. Doing so will send the order to the kitchen, as well as update the table to orange for awaiting food. Users will be brought back to this page on submitting the order, and as you can see, the table colour has now changed. In the kitchen view, orders are sorted on a first-come, first-served basis. Each order card displays the items to prepare, the time the order was placed, and contains a button to let the kitchen update the status of the order. This updates the table, changing the table's colour to green and displaying an alert for the waiter. As you can see, the table has updated. Now I will show you the admin view, which has a few more features. As you can see, the admin also has access to the table and kitchen views. In addition, admins can add new food items to the menu. Admins can also edit existing food items and create new users. Now, Joe and Zach will take you through our tech choices for Table Tracker.
We began our project by creating the design of the app. To do this, we used Figma, a user interface design tool. We started by discussing how an order would move through the application. From there, we designed the pages based on our discussion and decided that splitting admin and staff views would be the best way of displaying our app. These designs gave us something to work towards when building our front end. We built our front end using React, Firebase for the authentication and Sass for the styling. Using React to build our app allowed us to practice what we had learned on the course. We considered using React Native but decided on React since we wanted our app to be used across multiple devices, specifically tablets for the waiters and desktop for the admin. We expanded on our knowledge by using React hooks for the first time and context for our state management. React also allowed us to develop the app as a progressive web application. This meant that users could use the app regardless of their device, which was a key aspect of how we imagined it would be used in a restaurant setting. We carried out the styling using Sass. As the app is used in a practical setting, we decided to keep the style simple and functional. For authentication, we used Firebase's built-in authentication. The reason we chose to use this service was so that we didn't have to store user passwords in our own database. I'll now hand over to Joe, who will speak about how we built our backend.
Our backend was built using Node.js and Express framework to connect to a PostgreSQL database. We used test-driven development using Jest testing framework and utilizing Supertest for HTTP assertions. The API was created using RESTful principles using Express.js web framework to allow us to easily set up a local connection, handle routing, and other custom middleware such as error handling. The error handling across the models and controllers in the MVC architecture of the API was created using JavaScript promises. Next.js was therefore an easy choice as a query builder for the backend, which used also promises and allowed us to avoid writing raw SQL code in the project. The database of choice for the project was PostgreSQL. It made sense to choose a relational database for this project due to the many reference data fields across our tables. Using SQL also allowed us to handle one-to-many relationships in our data using junction tables, in our case where many foods could be related to a particular order. I will now hand the presentation back to Ayako, who will run through the problems encountered on the project.
During our application development, we came across some challenges. Due to this project being the first opportunity to develop code in a larger team, we had some challenges with Git version control. One issue was merging into the main branch from multiple sources where we encountered overwritten tests in the shared file. To fix this, we set a clear process before merging into the main branch. Socket.io was scoped out as an extra feature for the project, which was an option to update orders in real time in the kitchen view. However, after building the MVP, we did not have sufficient time to implement this feature. Our minimal viable product currently has a page refresh using a timer and requests. However, this could be upgraded in the future. That's all we have for you today. Thank you for watching our presentation.